Space is silent, but silence does not mean empty. In the frozen shadows of distant moons, beneath oceans trapped under ice, inside clouds thick with acid, and in geysers that erupt into the darkness, something might be alive. For centuries, we have asked, are we alone? But today, the question becomes smaller, closer, more uncomfortable. Is life hiding inside our own solar system right next door? Because life may not need sunlight. It may not need air. It may not need Earth. If life can survive boiling vents, frozen deserts, and toxic skies, then our solar system becomes a very different place. Tonight, we explore every world where science whispers, maybe? When the solar system changed, there was a time when our solar system seemed simple. A bright sun, a blue Earth, red Mars, a few gas giants, and cold dead moons. But that picture shattered. Rovers found dried rivers on Mars. Spacecraft discovered oceans under ice. Moons erupted water into space. And planets once thought impossible began to look promising. We realized something stunning. Earth might not be the only world where chemistry tried to become alive. So we begin our journey, from planets scorched by fire, to moons frozen in silence, to oceans that have never seen sunlight. Mars. The planet that shouldn't be dead, Mars, is quiet today, a cold desert with thin air and dust storms that can swallow continents. But silence can hide history. Billions of years ago, Mars had rivers, lakes, rainfall, magnetic fields, and an atmosphere thick enough for warm oceans. Not imagination, not theory. Evidence. Rovers photographed riverbeds carved like ancient scars. They found clay minerals that form only underwater. They discovered sediments stacked like pages of a forgotten book. So we ask, if Mars once looked like Earth, did something swim in its oceans? And if it did it vanish? Was it erased? Or did it retreat underground, protected beneath ice, waiting? Even now, methane appears in the Martian air, sometimes rising, sometimes disappearing. On Earth, methane often comes from life. On Mars, we don't know. But Mars gives us our first whisper. Life might not need Earth to begin. If Earth is life's first home, Europa may be its second. Under Europa's bright, cracked shell of ice lies a global ocean, vast, deep, and completely hidden from sunlight. This ocean contains more water than all of Earth's oceans combined. In the darkness, heat rises from the moon's rocky core. Hydrothermal vents pump minerals and energy upward, just like the vents where life on Earth may have begun. So we ask, if life started in Earth's deep oceans, why not here? Europa has water heat chemistry and billions of years of stability. It is one of the strongest candidates for alien life in the entire solar system. A world with an ocean and a secret waiting in the dark. If Europa whispers, Enceladus shouts. This small moon of Saturn, barely the size of England, erupts water from its internal ocean straight into space. These plumes blast 10,000 kilometers high through fractures called tiger stripes. When a spacecraft flew through them, it found salt organic molecules, warm water, and chemical energy strong enough. This isn't speculation. This isn't theory. This is data. Enceladus is actively pushing the ingredients of life into space, as if inviting us to sample it. So we ask, if a world has water, energy, and organics, Can it truly be empty? Titan is the strangest world in the solar system. It has rivers, but they're made of methane. It has lakes, but they're filled with liquid natural gas. It has rain, but it falls like cold gasoline from an orange sky. And yet, beneath that alien surface, Titan hides a second ocean, a real water ocean insulated beneath miles of ice. 2 layers. 2 chances for life. Surface life might be methane-based, a form of biology Earth has never witnessed. Subsurface life might be closer to our own. Titan asks a dangerous question. What if life doesn't need water at all? Venus is hell. Its surface is hot enough to melt lead. Its pressure can crush steel. Its atmosphere is a toxic cloud of acid. Yet, 50 kilometers above that deadly surface, conditions become surprisingly familiar. Temperatures similar to Earth's normal atmospheric pressure, water vapor, and sunlight. And in 2020, scientists detected phosphine, a molecule often produced by microbes on Earth. Maybe it was a mistake. Maybe a chemical we don't understand. Maybe a clue. If Venus was once a water world, could something have survived the planet's transformation by drifting upward into the clouds? We don't know. But the question refuses to die. Ceres may hide salty reservoirs. Pluto has nitrogen glaciers. Triton has cryovolcanoes. Even comets carry organic molecules. Everywhere we look, ingredients appear. Maybe life is rare, maybe fragile, or maybe incredibly common, but incredibly quiet. Here is the paradox. Our solar system is full of oceans, chemistry, heat, and time, everything life needs. So why haven't we found it? Maybe we're too early. Maybe we're too late. Maybe life never had the right conditions to grow big. Or maybe it exists simple, microbial, hidden, waiting for us to learn how to detect it. Perhaps life doesn't announce itself. Perhaps it whispers. The solar system is not empty. It is alive with possibility. Oceans in the dark, moons that breathe water, planets that hide secrets in their clouds. If life began once, why not twice? Why not 1,000 times? Before you leave, consider this. What if the closest alien life isn't light years away, but already here, waiting beneath a frozen shell? If you want to explore more mysteries, from ancient minds to cosmic questions, subscribe, share your thoughts, and join us on the next journey. Because the next discovery might not be out there. It might already be in our solar system, waiting.